Yes. So already we discussed some problems related permutations and combination just for observation purpose and for idea purpose what type of questions they are going to frame on this topic particularly, right? So now we look at permutations and combination. So permutations and combinations. So for calculation purpose that factorial values are important. We know already 0 factorial means 1. 0 factorial is nothing but 1. 1 factorial means 1. 2 factorial means 2 into 1, nothing but 2. 3 factorial means 3 into 2 into 1, 6. 4 factorial value, right here can write 4 into 3 factorial or 4 into 3 into 2 factorial or 4, 3, 2, 1. Value is same 24, but for easy calculation purpose we can rewrite that 4 factorial into 4 into 3 factorial or 4 into 3 into 2 factorial or 4, 3, 2, 1. For our easy simplification purpose we can rewrite it. Suppose 5 factorial means sometimes we can use 5 into 4 factorial or 5 into 4 into 3 factorial, but that value is always same. 6 factorial means suppose 6 into 5 factorial or 6 into 5 into 4 factorial, like that. But the entire 6 factorial value is no change. 7 factorial, maybe 7 into 6 factorial. So this value cannot change it, but we are rewrite that factorial for easy simplification purpose. Suppose in the numerator 20 factorial is there, in the denominator 18 factorial is there, then 20 into 19 into 18 factorial divided by 18 factorial. This 18 factorial cancel, then 20 into 19, 380. For simplification like this, so we can rewrite that factorial into like this also. Alright. These all are the, we know that 10 factorial means, so 10 into 9 factorial or 10 into 9 into 8 factorial, like that we convert, and after that we go for simplification for easy calculation purpose. That's it, right? These all are some basics actually. We know that all factorial values, but in permutations and combination, the P calculations and C calculations are there. So the P calculation, suppose I take one value 5P1, 5P2, 5P3, then 5P4, 5P5. These are the how we are going to end. 5P1 value is 5. 5P2 means we need to product in the decreasing order up to 2 terms. Base is 2 na, up to 2 terms. 5P3 means up to 3 terms in decreasing order. 5 into 4 into 3. 5P4 means 5, 4, 3 into 2. 5P5 means 5 into 4 into 3 into 2 into 1. It is nothing but 5 factorial. So like this we are going to convert. Suppose 10P2 value is how much means 10 into 9. 7P3 value is how much mean up to 3 terms. 7 into 6 into 5 in the decreasing order from 7 onwards. So like that we rewrite that value and simplify the P calculation. 22P1 means 22, only one term of 2, like that. So 52P3 means 52 into 51 into 50. So like that we are dividing, we are converting these values into products. After that simplification we will get exact value. So these are, but these are actually for calculation purpose, but general notations are, I mean some formulas are there actually. NPR, generally we can written as n factorial by n minus r factorial. Suppose if I took that 5P2, 5 factorial by 5 minus 2 factorial. 5 factorial I am writing like this, 5 into 4 into 3 factorial. 5 minus 2 means 3 factorial. These two are cancelled, the remaining terms are 5 and 4, only 2 terms. So after simplification by using this formula, we get those 5 into 4. So instead of using all times to that formula, we directly written as like this way. For simplification purpose, we choose that easy way. So 7P3 is how much means 7 into 6 into 5. 9P4 is how much means 9 into 8 into 7 into 6, up to 4 terms only in the decreasing order, like that. So NPR is always is equals to n factorial by n minus r factorial. Similarly, NP1 equals to N means 5P1, 5, 10P1, 10, 100P1, 100 like that. And similarly, NPN is equals to N factorial. So these are the three important notations in P calculation. Means 10P10 is nothing but how much? 10 factorial. 6P6 is how much? Means 6 factorial. So like that we are going to simplify this P calculation. Very simple. That's it. Similarly, for here only we discuss that C calculations also. C calculations. Suppose 5C1 value is how much? 5C2 is how much? 5C3 is how much? 5C4, 5C5. How we are going to write means? So 5C1 means 5 by 1. For permutations, only multiplication in the decreasing order for up to that base term. But here you need to divide that base terms also. Suppose 5C2 means, observe here, 5 into 4 up to 2 terms. In the denominator, the 2 factorial means 2 into 1. 5C3 means 5 into 4 into 3. In the denominator, 3 into 2 into 1. 5C4 means up to 4 terms. 5 into 4 into 3 into 2 divided by 4 factorial means 4, 3, 2, 1. In the denominators also, we get same number of terms. So, whatever the numerator. 5C5 means 5 into 4, 3, 2, 1 divided by again 5 factorial 5, 3, 2, 1. So just observe, all are cancelled here. Answer is 1. Just observe here, 4, 3 to 4, 3 to cancel. That 5 value. Right, sorry. 3, 3 cancel. 2 1s, 2 2s, 5 2s, 10 value. Here 2 1s, 2 2s. Here also 10. This value means 5. Observe this. 5 and 5 equal. So 5C1 is equals to 5C4. 5C2 equals to 5C3. Just observe these two values. Bases observe here. 1 plus 4 equals to how much? 5. 2 plus 3 equals to how much? 5. If the bases are equal, then their values are also equal. Again, that will also helpful. Suppose if we need to find out 10C9 value means 10 into 9 into, we need to write 9 terms. Instead of writing 9 terms, so sum of that base equals to same equals to n, then how much is remaining left? Means 9 plus 1, 10. Means 10C9 is also equals to 10C1. The 10C1 value is how much? Means 10. Directly we can write that. Suppose 20C18 value we need to find out. Means no need to write up to 18 terms. Instead of writing up to 8 terms, so just it convert like as 20C2. Why? Means 18 plus 2 equals to 20. That is equals to the total n value. Now 20C2 is very simple. 20 into 19 by 2 into 1. After that, 2 1s, 2 10s, 19, 10. That simplification is depends on individual purpose. So if we are good at calculation, so we can do it fastly. If we are little bit slow, so we will take some time, right? So these are the C calculations. Similarly, same as it is, general notations are there. So C means so whatever the terms, and I again decreasing order in the numerator, but in the denominator again those terms are repeated. 1 means only 1, 2 means denominator 2 factorial, 3 means in the denominator 3 factorial, like that. So again for this also we have general notations. What means generally? NCR equals to n factorial by n minus r factorial. It is nothing but p value. This is nothing but a product of terms up to decreasing order, but extra in the denominator r factorial will come. That's why in the denominator we write that 1 means 1, 2 means 2 factorial, 3 because of this r factorial. In the here NC0 is equals to NCN equals to always 1. This is also important. Means 10C10, 10C0, 100C100. So 99C99. These values are always equals to 1. Suppose similarly NC1 is always equals to 10. 5C1 value 5, no need to calculate. 10C1 value 10, 8C1 value 8, like this. Similarly, if NCX equals to NCY, suppose if NCX equals to NCY, then must and should that x plus y value is equals to the total n value. These are the cases. means this can be written like this also. NCR equals to NCN minus R. This is also fine. If 10C4 equals to 10C6, 6 plus 4, 10. Like that also we can rewrite for only easy calculation purpose. But these are, we are not generally used only for mathematical related type of questions. We can use these things. Right, observe any PYQs of CSAT, they are not asking about skills in mathematics. They are always trying to logical oriented test to logical oriented skills of the students. That's why we are not expecting questions from this concept exclusively, but this will be helpful for solving some simplifications in the problem. That's why we are discussing here. Now we move into permutations. Very, very, very important. Permutations is nothing but arrangements. So simply seating arrangements in a row or in a circle, whatever arrangements. Suppose two persons A, B are there. In how many ways we can arrange them in seating order? AB is one way, B and A is also one way. Two different ways. Persons are same, AB, BA, both are the two persons are there, but we use the two at a time, and in how many ways we can arrange them means either AB or BA, two different ways. Similarly, observe ABC, three persons are there. We use all at a time. We need to seat them by all ABC in a seating order. In how many ways means, right? ABC one way and ACB also one way. BAC and BCA, CAB and CBA. How many ways? 6 different ways we can arrange them. So, 3 persons are same, A, B, C. Those are the 3 persons, but we are here arranging in different ways, A, B, C, A, C, B. But again, in all the 6 ways, so only those are the 3. We are using 3 at a time. In this case also, we are using all, but in ABC, we need to arrange 2 at a time. So, out of ABC persons, we can arrange 2 at a time. Total how many ways means general observation A comma B, B comma A. Then A comma C, C comma A. B and C, CB. How many ways? 6 different ways. So how we are going to find? So okay, so sir, 2 persons are there, 3 persons are there. Very easy to find out. But 10 persons are there, 20 persons are there, 30 persons are there. It is not possible to find out all possibilities and writing all the cases. It is analyzing and give the exact answer. That's why how we are going to win. So suppose 2 persons are there, all at a time means n persons arrange themselves in n factorial ways, simply by all at a time. Suppose 2 persons are there, we arrange 2 factorial. 3 persons, so we are going to arrange 3 persons at a time means 3 factorial. But just observe here, 3 persons are there. Out of 3, we are going to choose 2 at a time, and how many ways we are going to arrange them means total are 3 persons. We need to arrange 2 at a time. 3p2, nothing but 3 into 2, 6. Simple. Here 3 factorial, 3p3, nothing but here also 3 at a time is 3p3. 3p3 value is 3 factorial. That's why I am writing 3 factorial. Otherwise 3p3 is also correct. Here 3p2. If 1 at a time means 3p1 only. 1 at a time. What are that means? A is separate, B is separate and C is separate. Only 3 ways, 3p1. So like that we need to, not only persons, for letters also. Suppose a word, suppose board is there, BY. So board is there. In how many ways we can arrange by using all the letters of the word? Board. All the letters of the word are, how many letters are there here? 5 letters. We need to use all the words. All the letters of the word means we need to form 5 letter words. How many ways means 5p5, nothing but 5 factorial, that value is 120 ways. Or 6 boys are there. In how many ways we can seating them, we can arrange them? mean 6 boys are there. In how many ways? All 6 at a time means 6p6, nothing but 6 factorial. 2 at a time means 6p2. 3 at a time means 6p3. Like that, we are going to solve all these permutations related questions actually. Then again, very, very important. We can go for that some similar cases. Suppose. Now, suppose we are going to use so all the letters at a time, but each letter used once means no repetition here, right? We are discussed at the basic question. So what means that repetitions are there? We can use, suppose 5 letters, 5 numbers are there, 5 into 5 into 5, 4 into 4 into 4. But here each letter used once. So how we are going to find out? First, all the letters at a time, right? Some cases we already see board in how many ways means 5 letters are there, all at a time here, 5 factorial means. Suppose brain, again 5 letters, 5 factors. Ordinary, suppose how many ways means 3 plus 3, 6 plus 2, 8. 8 factorial ways. That's clear. But observe here, R and R, 2 R's are repeated. Here, 2 R's are repeated. So, suppose if I am framing one letter, O-R-R, D-I-N-A-Y. Suppose this is the one letter. So, if this R and this R are replaced also, again we get same word. O-R-R, D-I-N-A-Y. So, some repetition of words are there. Why means that R is repeated. How many repetitions are there? Again, it is not possible to write. That's why whatever the repeated letters are there, you need to divide that repetition of letters. Means 8 factorial by 2 factorial is the exact solution for this ordinary. Ordinary, how many ways we can arrange by using all the letters at a time, each letter used once. Sir, R is, yes, we are using each letter at a once, but R, 2 R's are there. That's why we are using this R one time, this R also one time. That is the case. So, 2 different letters are there. That's why 2 times we have. So, ordinary can be arranged in how many ways means 8 factorial by 2 factorial ways we can arrange. Similarly, you go for that. Engineer, suppose in how many ways we can arrange? So 3 plus 3, 6 plus 2, 8. So 8 can be arranged in 8 factorial ways, but E is here also E, here these two also is E, 3 E's are there. That's why in the denominator 8 factorial by 3 factorial ways we can arrange by using the all letters of the word. And still not over. Observe N also 2. 2 N's are there. That's why you need to write 2 factorial also. N number of letters are repeated. You need to rewrite in the denominators also. 3 E's are there. That's why 3 factor. 2 N's are there. 2 factor. G, I, R are different letters. That's why I am not writing any case. So like this, suppose mathematics is there. Mathematics word. In how many ways can we arrange by using all the letters of the word mathematics? So 3 letters plus 3 6 plus 3 9 plus 2. Total number of letters are 11. So 11 letters can be arranged in 11 factorial, but some repetitions are there. 2 M's are there, 2 A's are there, and 2 T's also there. Then HE separate, IC, S are different letters. So in the denominator 2 factorial into 2 factorial into 2 factorial. This is the case. Simplification is different. 11 factorial, 11 into 10 into 9 into whatever the value you write, and 2 into 2 into 2, and simplify cancellations, what the resultant number you will get. 8 factorial means 8 into that. If you know direct value 40320, direct you write, and 3 factorial 6 into 2. Like that you need to calculate. So first this core concept is important. Writing this is important. After writing this, simplification is very easy, no doubt. If you practice some 2 or 3 times, very easy. Now, Sometimes there is a chance of asking question. Suppose here we are using all the letters at a time, each letter used once. How many ways we can arrange? Arrange means these are all the correct, but sometimes rearrange question in how many. That's why we are always be careful while reading the question in entire CSAT. There is a small twist, so that's why at the time of question reading we need to receive that core concept, what they are asking and what we need to understand from the question and how to approach to solve that questions. That is our important. So rearrangements in that 5 factorial words, that board is also one letter. It is repeated starting with the B, O, A, or D. Definitely it is also one word in the anywhere in 5 factorial total letters. So that's why you need, any case, rearrangements, you need to subtract one word for total possibilities. 5 factorial minus 1 ways we can rearrange that board word. 5 factorial is the arrangements. In that board is also one word. That's why we remove that one time. Here also brain in rearranged in 5 factorial minus 1. Ordinary can be rearranged in 8 factorial by 2 factorial minus 1 way. Similarly, engineer also 8 factorial by 3 factorial into 2 factorial minus 1 way. So 11 factorial by 2 factorial into 2 factorial into 2 factorial minus 1 way. So like this we can rearrange it. So rearrangement means we need to subtract one word. What is that one? Whatever they given in the question. That word is repeated in total ways. That's why we subtract that word and we will get rearrangements are how many. This clear? Very, very important. Right. So now, so almost we have some clear idea. Now we'll move for one more card. Now, what means? Here, I take one example. All come together. Here also I write all vowels come together. Then no vowels, suppose. So all vowels never come together. All vowels never come together. Right. 3 different concepts. Here no 2 vowels come together. These are again very, very important. Suppose I took any word, so whatever it is, suppose we already solved this, no? Board, brain. So if I took board, why means all are different letters. First we will discuss there, then we solve some problem. Suppose if I take that board, right? Now, board can be arranged in how many ways we know? Total of 5 factorial ways. We can arrange by using all the letters of the word in the board. Yes. Now, all vowels come together. In board, vowels are O and A. 2 vowels are there. First, all vowels come together means group vowels and consider as single letter. Actually, 5 letters are there. 2 vowels. Suppose if I am taking these 2 vowels come together means they are always side by side. Right, clear? So that 2 vowels must be placed at this or maybe this 2 or this 2 or this 2, whatever it is. Just 2 vowels. The 2 letters come together and consider that as one letter. Now 1, 2, 3 consonants plus vowels as a group considered as single letter. 3 plus 1. 4 letters can be arranged in how many ways means 4 factorial. Then that 2 vowels, O and A and O, right? OA is also one way, AO is also one way. Means 2 vowels can be arranged themselves in again 2 factorial ways. So all vowels come together means, so how many ways means first you need to three consonants, whatever they here board three consonants. First you need to total number of five letters. In that segregate how many vowels are there. Just group that vowels as single unit and consider that vowels group as a single letter. 3 plus 1 4. 4 letters can be arranged in 4 factorial into 2 factorial. This is the resultant. All vowels come together. Suppose question may be framed 5 boys and 6 girls. All girls 6 sit together. That is also same. Instead of vowels, we make that 6 girls into a group and consider as single letter. Like we will discuss that also. Now, all vowels never come. Instead of vowels, they form boys and girls or numbers, whatever it is. So all are correct only. All vowels never come together. Here, all vowels come together. Here, all vowels never come together means total minus all come together. This is important again. Total ways minus all vowels come together. If we subtract this value, then the remaining nothing but all vowels never come together. Here, total are how many? 5 factorial minus all vowels come together are how many? 4 factorial into 2 factorial. That's it. 5 factorial value 120. Here 4 factorial 24 into 2 48. Minus 48 is nothing but 72. That's it. Simple. All come together 48 ways. So consider that group vowels as group and 4 letters can be arranged in 4 factorial. Then all vowels never come together means total 5 factorial ways minus 4 factorial into 2 factorial. If repetitions are there, we can use that repetitions in the denominator also. In this question, repetitions are not there. That's why we are writing directly. Now that is important. No vowels come together. No vowels come together means here, observe carefully. First, you need in this, first we place consonants. How many consonants? 3 consonants. Suppose 1, 2, 3. 3 consonants placed and no 2 vowels come together means maybe 2 vowels either side of this consonant or either side of this consonant or either side of this consonant. There is a chance. Suppose here we observe these two. Suppose I am writing like this. O, B, A, R, D. Here, 2 consonants are side by side. But question is asking no 2 vowels come together. Means there is a chance of consonants may be come together or side by side. This is acceptable. But OA and AO, these are the not possible. If suppose 3 vowels are there, no 2 vowels also not need come side by side. That is the condition. That's why first you need consonants. First you need to arrange consonants. How many consonants are there? In this question means 3 consonants are there. The 3 consonants I arranged first. In how many ways? 3 consonants can be arranged in how many ways? 3 factorial ways. Yes? Clear? No repetitions are there. B or D, 3 different. Now observe. Vowel comes in any place, either here, 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 here. Those are nothing but that gaps. How many gaps are there? 1, 2, 3, 4. 4 gaps are there. In those 4 gaps, you need to fill with how many vowels? Only we have 2 vowels. 4 gaps and 2 vowels. How we can arrange them means 4 gaps are there. 2 vowels can be arranged in how many ways? 4p2 ways. Suppose 3 vowels means 4p3. 4 vowels means 4p4. Like that. That's it. You need to find out how after arranging consonants in the middle of that consonant how many gaps are there. After finding the gaps, you need to arrange whatever the vowels present in the given word, that you need to arrange like this. 3 factorial value is 6 into 4p2 means 4 into 3. 24 into 3, 72 ways. That is the answer. That's it. Simple. So like this, you need to solve any type of question. All come together, all never come together, no 2 come together. Maybe that vowels, boys, girls, whatever it is. Yes, okay. Now, similarly, you apply repetition case. Suppose, what is, if we go for that engineer word or ordinary, anything is, engineer we go for this engineer word, right? Now, give all. If I go for this engineer, total already we find out. So total are 8 factorial by 3 factorial into 2 factorial. Why means 3 e's are there, 2 n's are there. That's why we are writing engineer total ways are there. Now, right, not only need necessary all vowels, instead of all vowels, all consonants come together. Questions may be framed like this. Concept is means same only. Suppose here all vowels come together. Just solve this. Observe here. All vowels come together. How many vowels are there? E, I, E, E. 4 vowels are there. N, G, N, R and A. These are consonants. So 4 vowels are there. Total 8 letter word. 1, 2, 3, 4, 5, 6, 7, 8. These 8 letters can be right arranged, but that 4 consonants, 4 vowels can be grouped as a single letter. 1, 2, 3, 4, 5. Total how many? 5 factorial ways. Just observe. In consonants, any repetitions are there? 2 n's are there. That's why I am writing 2 factorial. 5 factorial by 2 factorial. Let's clear up. Why means 2 n's are there? That's why I am repeated. And next, that 4 vowels arrange themselves in how many ways? That is important. That 4 vowels arrange themselves in 4 factorial ways. That's clear, no doubt. 4 letters are there, 4 gaps are there, 4 factorial. But in vowels, 3 e's are repeated. That's why you need to divide by 3 factorial. This is the answer. That's it. Very simple. So in engineer, all vowels come together in how many ways we can arrange by using the all letters of the word means that 4 vowels are present. That's why we form as a group of that 4 letters and consider as single letter. 4 plus 1, 5 factorial. In this entire 2 n's are repeated. That's why I divided by 2 factorial. And that group, in that group, 4 vowels can rearranged or reshuffled themselves in 4 factorial ways. But in that 4 vowel, 3 e's are present. That's why again I divided by 3 factorial. That's simple. Now, all vowels never come together question. That's simple. Now, total is total minus all come together. That's simple. That's it. All come together. So, total 8 factorial by 3 factorial into 2 factorial minus here 5 factorial into 4 factorial by 2 factorial into 3 factorial. That's it. This is the answer. That simplification matters. No problem. Right? Simple. Next. One more case. All vowels come together. All vowels never come together. Not. No 2 vowels come together. No 2 vowels come together. Now you need to arrange first consonants. How many consonants are there? 4 consonants. 4 consonants can be arranged in how many ways? 4 factorial by 2 factorial. Why 2 factorial means 2 n's are repeated. That's why 4 factorial by 2 factorial. And how many gaps are there? After this, 1, 2, 3, 4, 5 gaps are there. In those 5 places, you place any place of that 4 vowels, remaining 4. In that 5 gaps, you used that 4 vowels to fill that. 5 gaps are there, 4 vowels can be arranged in how many ways? Right, gaps are 5. Then 4 vowels in 5 gaps. In how many ways means? 5p4. That's it. So, total resultant is 4 factorial by 2 factorial into 5p4. It's not over. Why? The 3 factorial is why? 3 e's are repeated in the vowel. E. That is the clear. 3 factorial. That's it. So if repetitions are there means you need to divide that how many number of times the letter is repeated. That's it. Simple. Right? Very easy. Now we look one more example. Right? Very easy. Suppose if I write 4 boys and 6 girls are there. Now, all boys come together. Here, total how many ways? Total how many ways? Total 10 members are there, 10 factorial. That is important. Boys and girls completely combined 10 members are there, 10 factorial. All boys come together. How many means? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 members are there. All boys can form a group and considered as a single 6 plus 1. 7 factorial, that 4 boys can be arranged themselves in 4 factorial. Here 4 boys, there is no repetitions in the persons, right? So separately, definitely 4 persons are different, that's why. So 7 factorial into 4 factorial, that's simple. So total all boys come together means you make that 4. Next, all girls come together. Right, all girls come together means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You need to make 6 girls as a group. 6 girls as a group. 4 plus 1. 5 factorial into 6 factorial. That's it. Simple. Next. All girls never come together. Means total 10 factorial minus all comes together are 5 factorial into 6 factorial. That's it. Answer. Then all boys never come together. All boys never come together. Total 10 factorial minus 7 factorial into 4 factorial. All boys come together. That's it. Then now, no 2 boys come together. Just observe here. No 2 boys come together. Means you need to first arrange 6 girls. So girls in how many ways? 6 factorial ways. Then gaps are 1, 2, 3, 4, 5, 6, 7. In this 7, you need to place 4 boys. 7p4. That's it. This is okay. Next, no 2 girls come together. Suppose no 2 girls come together. Just observe here. You need to first observe, arrange 4 boys in 4 factorial ways, but 1, 2, 3, 4, 5. Gaps are 5, but girls are 6. Is it possible to fill that 6 girls in 5 gaps? If I place 5 girls means always 1 girl is left. Suppose if I take 1 more means 2 girls side by side, means this condition never exists according to given data. That is also important. 4 boys and 6 girls, no 2 boys come together means okay. No 2 girls come together is not possible to find out. Data inadequate or can't be determined based on that given conditions. So this observation is also important. So like this, we are going to solve any type of questions from permutations and combinations. Like all come together, all never come together, and no 2. Right, maybe that boys and girls are digits related or letters related, whatever it is, we can go and solve entire like this. That's it. Very simple. Now, some cases are there. Right, circular arrangements. All right. Just observe. AB are there. We are going to arrange in circle AB. In how many ways means AB and BA also here only repeated. AB and BA both are same in circle. Why means AB or BA both are observed in the one condition. So ABC are there. Suppose ABC means how many ways? ABC, ACB, then BAC, BCA, CAB, CBA. These are the 6 arrangements we observe in the row based arrangements. So if I write here A, B, C, ABC, yes, covered. If I start from B, BCA, BCA, it is also covered. Next CAB, it is also covered. 3 are covered at a time. And if I write one more possibility, in the middle of A and B, C, ACB completed, then BAC completed, then CBA, this is also completed. Only 2 different possibilities are there when we arrange in the circular by using the 3% at a time. So always it is not possible to, right? So that's why. So n items can arrange in the circular in n minus 1 factorial ways. In circular arrangements, so n minus 1 factorial ways. Suppose 2 persons are there, 2 minus 1 means only one way. That's it, 1 factorial. 3 persons are there, 3 minus 1, 2 factorial. Value is 2 ways. This one is 1, this one is 1. So like that, when it goes, suppose 10 persons are arranged in a circle, then how many ways means 10 minus 1, 9 factorial. Yes, we can arrange them. Suppose now 4 boys and 4 girls are there. How many ways we can arrange that 4 boys and 4 girls in a circle? Total 8 members are there. So total 8. 8 can be arranged in 8 minus 1 factorial. So 8 minus 1 factorial ways we can arrange it. But all girls at it sit together means 1, 2, 3, 4. These are the all girls, and 1, 2, 3, 4. These are the all boys. Thus again, this all girls make as a single group. We know that single group means it convert 5. 4 plus 1, 5. 5 can be arranged in how many ways? 5 minus 1 factorial ways. But that 4 girls shuffle themselves in how many ways? 4 factorial ways. In 4 factorial into 4 factorial ways. So like this we are going to solve. 4 boys and 4 girls are arranged in a circle in how many ways? 4 factorial into 4 factorial. Similar, suppose if 4 boys and 4 girls arranged in a circle, it's a row, then how many ways? That 4 can be a group. 4 plus 1, 5 factorial into that 4 can be arranged themselves in 4 factorial. Here 4 factorial into 4 factorial, it is 5 factorial into 5. 10 boys and 10 girls, 10 factorial into 11 factorial in a row. But in a circle, 10 factorial into 10 factorial, like that. So we practice some questions, then we are ready to solve same questions in the fraction of seconds only. That's why we are discussing entire concepts here. Right? So 6 boys and 6 girls are arranged in circular in how many ways? 6 factorial into 6 factorial ways. But in a row means 6 factorial into 7 factorial ways. By practicing, we need to improve ourselves to solve same type of questions in the fraction of seconds only. That's why we are listening these classes, we are practicing so many problems, we are analyzing some PYQs in the class itself here. Right? So these are some circular arrangements. Again, sometimes in circular, either clockwise or anti-clockwise arrangements. So maybe there is a chance of asking questions in clockwise and anti-clockwise arrangements. Clockwise and anti-clockwise arrangements, or sometimes a necklace. So in necklace type means number of beads. Suppose 10 beads are present, how many ways we can form a necklace? Like that, there is a chance of asking some questions. For this question, n items can be arranged in a clock or anti-clockwise in how many ways? N minus 1 factorial by 2 ways. This is clear. Suppose same 10 persons can be arranged in a clockwise of circle means 10 minus 1 factorial by 2 ways. Right? Suppose 20 beads are there, in how many ways we form a necklace means 20 minus 1 factorial by 2 ways. So like that we are going to solve. So these are some permutations related concepts actually, right? Any observe, and once again you go through all the concept, you have clear idea. Right? By the end of this, I can take one example. All are different letters. So rainbow is one word given by the examiner. Now they are asking, by using all the letters of the word, total how many ways can we arrange the rainbow? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 7 factorial ways. Suppose how many ways we can rearrange the question may be formed like this. 7 factorial minus 1 way. Yes, simple. Now vowels, all vowels come together. Give answers. How many vowels are there now? A is one vowel, I is also one vowel, O is also one vowel. Three vowels are there. 1, 2, 3, 4, 5, 6, 7. Out of 7, 3 vowels come together means 4 plus 1. 5 factorial into the 3 vowels again themselves arranged in 3 factorial. That's it's very simple. Just you need to observe all vowels come together in 5 factorial into 3 factorial. All consonants come together in how many ways? 1, 2, 3, 4, 5, 6, 7. But 4 consonants can form into a group. Then 3 plus 1. 4 factorial into 4 factorial. So clear. Now the right. How many number of words can be formed by start with R and end with W, suppose. Total 1, 2, 3, 4, 5, 6. Last letter is always W, first letter is R. 2 letters already used. And here it is one way, here it is one way. Remaining 5 letters can be arranged in the 5 gaps in how many ways? 5 factorial ways. Sometimes questions may be framed like this. And vowels at odd positions. Right, vowels at odd position. 1, 2, 3, 4, 5, 6, 7. Odd position means 1, 3, 5, 7. In that 7 positions, sir, 4 positions are odd. Out of 4, we can use any places for filling A, I, O. 3 vowels. 3 vowels can be filled in the 4 places in how many ways? 4P3. Right? Still, how many gaps are there? That is important. Only I used 3 vowels means either first 3 or second 3, whatever. But one gap is again right empty, vacant. So that one gap and 3 even position. Total still 4 vacant position. 4 gaps are there. Why means so we used only for vowels 3 places, but still one more remaining. They given vowels at odd position means consonants may be either odd positions or even position. That is possible. So that's why 4P3 into remaining 3 vowels placed, remaining 4 gaps is there. That in that 4 gaps we placed 4 remaining consonants in how many ways? 4 factorial ways, like that. So vowels at odd positions. So like this also, right? So suppose all vowels never come together. Total 7 factorial minus 5 factorial into 3 factorial, like that. Now, no 2 consonants come together. No 2 consonants come together means first you need to fill vowels. Vowels, 3 vowels in how many ways? 3 factorial ways. Now gaps are how many? 1, 2, 3, 4 gaps. Consonants are also how many? 4. 4 consonants and 4 gaps. In how many ways? 4 factorial ways. This is the all no 2 consonants come together in how many ways? 3 factorial into 4 factorial. Suppose no 2 vowels come together means no 2 vowels come together in how many ways means so no 2 vowels means so first you need to fill consonants 1, 2, 3, 4 consonants can be arranged in 4 factorial. Now gaps are how many? 1, 2, 3, 4, 5. 5 gaps are there. In 5 gaps, how many vowels are there? 3 vowels can be filled in how many ways? 5P3. In that case, like this, you need to solve. Right, not only this, again some alternative arrangements they are asking again. Right, these are some yes, and rank of position of that word. Suppose if dictionary order starting with A, then B, then N, I, N, O, R, W, like that. Right, total of 7 factorial means 5040 words form in that 5040. Which position we get rainbow? That type of questions are the rank of position of rank or position of the given word in the entire arrangement. So that type of questions are also there, but we'll discuss later at the end of concept. We will discuss that. Now we see that alternate arrangements. Now Alternative arrangements. This generally maximum there is boys and girls or males and females, those type of things. Suppose if 4 boys and 4 girls are there, how can we arrange that alternatively? Means first we can arrange all boys. Now just girl, it is also one type. Similarly, boy girl, boy girl, boy and girl, boy and girl. These are the two different cases. So this is also one case and this is also another case. Starting with girl and starting with boy. 4 boys can be arranged in 4 factorial ways. 4 girls can be arranged in 4 factorial ways. Into how many types? Starting with boy and starting with girl. 2 different ways. So if a number of boys and number of girls are equal, number of boys equals to x, number of girls equals to x, then alternative arrangements are x factorial into 2. Right? I am giving just for understanding purpose. Otherwise, starting with boy, starting with girl. 4 boys can be arranged in 4 factorial ways. Again, next 4 girls can be arranged in that 4 factorial ways. That's it. So starting with boy and starting with a girl. That's it. Similarly, 5 boys, 5 girls are there. How many ways we can arrange them? Means 5 factorial into 5 factorial into 2. 7 boys and 7 girls. How many ways? Means 2 into 7 factorial into 7 factorial ways we can arrange them alternatively. Here alternatively, boy girl, or girl, boy girl. Equal number of girls and boys, it is very easy. Suppose 2 girls and 3 boys are there, then suppose if starting with boy, girl, boy, it is possible. Starting with girl, boy, here boy. Here 2 boys are adjacent. Means second case is not possible. Why? Means if starting with the girl means definitely 2 boys are adjacent to each other. That is not an existing case. So that's why alternative means definitely boys and girls are alternative. Only one possibility case, that is boys can be arranged in 3 factorial ways. 2 girls can be arranged in 2 factorial ways. So number of boys and girls difference is 1. Number of boys equals to x. So number of girls equals to x minus 1 or x plus 1, whatever it is. Then alternative arrangements are x into x minus 1 factorial. X into x minus 1 factorial, right? Instead of that, suppose 4 boys and 5 girls are there. How many ways? 4 factorial into 5 factorial. 6 boys and 7 girls are there. 6 factorial into 7 factorial. 10 boys and 9 girls are there. 10 factorial into 9 factorial. First we arrange 9 girls like that. So these are the alternative arrangement. If boys and girls are equal, then 2 times of number of boys and number of girls factorial. If boys and girls are differ by 1, then directly multiply by number of girls factorial into number of boys factorial. If it is more than differ by 2, suppose 3 boys and 5 girls. Just observe. Boy, girl, 3 girls are over. Remaining 2 girls. Here, girls are adjacent to each other, not alternate. Suppose if I start with girl and boy, then girl, boy, 3 boys over. Remaining 2 girls are. If there is a chance of always either boys or girls are differ by more than 1, then it is not possible to arrange themselves in alternatively. That is important. Suppose, just give answer. If 4 boys and 4 girls, right? This one is clear now. So that's why either differ by 1 or equal means then only it is possible to arrange them in the alternative seating. Otherwise, it is not possible. Similarly, 4 boys and 4 girls arrange alternative in circular. So circular arrangements, 4 boys and 4 girls, in how many ways we are going to arrangement. So circle, first you need to either boys or girls, any case in 4 boys can be arranged in how many ways? 4 minus 1 factorial ways. Yes, clear? 4 minus 1 factorial ways. Now gaps are 1, 2, 3, 4. 4 gaps and 4 girls can be arranged in how many? 4 girls in 4 gaps. 4 factorial. Nothing but 3 factorial into 4 factorial. So in circle, only if boys and girls are equal, there is the only condition that is possible to sit in the alternate, to arrange in the alternative. If differ by one also, it is not possible to arrange in the circular way, right? Suppose 5 boys and 5 girls means simply first 5 boys arranged in 4 factorial and 5 girls arrange themselves in 5 factorial in 5 factorial. 10 boys and 10 girls. Or how many ways means 9 factorial into 10 factorial. We can arrange them in circular arrangements, right? So alternative sit each other. These are some basics regarding these permutations, right? We will continue in the next session for combinations also. After that, we solve some problem. Then, as usual, our CSAT PYQs, right? Then that rank or position that will discuss at the last actually, maybe at the end of concept, these combinations or practice questions like that we will plan, right? Thank you.